So the next question is, design the circuit shown in the figure to establish a DC drain current ID is equal to 0.5 milliampere. The MOSFET is specified to have your threshold voltage VT is equal to 1 volt and Kn dash W by L is equal to 1 milliampere per volt square. For simplicity, neglect the channel length modulation effect, that is, assume lambda is equal to 0. Use a power supply VDD is equal to 15 volt. Calculate the percentage change in the value ID obtained when the MOSFET is replaced with another unit having the same Kn dash W by L but VT is equal to 1.5 volt. It is asked for 8 marks from June-July 2021 question. Okay. So this is the given diagram. So you have a voltage divider biasing, VG is also given, RD value is given, RS is given, okay, and VDD is also given. So from the question, let us write first the given parameters. What are the given parameters? ID is equal to, for the first case, ID is equal to 0.5 milliampere. Then VT, threshold voltage, is equal to 1 volt. Kn dash W by L is equal to 1 milliampere per volt square. Then you have to assume lambda is equal to 0. VDD is equal to 15 volt. Now the second case, your VT is changed to 1.5 volt. Okay, these are the parameters which are given in your question. You have to change the percentage, you have to calculate the percentage change in the value of ID when the MOSFET is replaced with another unit, and design the, you have to design means you have to find out the values of the various parameters. What are the values you have to find out? You have to find out RG1, RG2. Okay, this is RG1, RG2, etc. Okay. So now starting off with the designing, as the rule of the thumb for designing the classical biasing circuit, we choose RD and RS, okay, to provide 1/3 of the power supply voltage VDD. So now we have to check whether your RD is equal to RS is equal to 10 kilo ohm also. If it is not given in your question, you have to find out the values of RD and RS, but in the figure now your value is given. Okay, so let us check whether it is correct. So 1/3 of the power supply voltage VDD as the drop across each RD, the transistor VDS and your RS. So there should be 1/3 drop across your RD, your VDS and your RS. So you can assume that what will be your value of VD. Now you can assume that VD is equal to 10 volt, drop is 5, right? So VS will be equal to 5 volt. Okay. So these are the two assumptions which you are going to take. So VD will be equal to 10 volt and VS will be equal to 5 volt based on this assumption. First case, what is since ID is equal to 0.5 milliampere, now you are going to find out the value for RD and RS. What will be your value for your RD and RS? You can use your KVL, output loop equation. Okay. So what will be your loop equation? VDD plus VDD. Here it is plus to minus. So take the second polarity, minus ID. What is the current flowing here? ID, right? And here also the current flowing will be equal to ID. So minus ID RD. First let us find out the value for your RD. So here it is plus to minus VDS, or you can take it as VD, right? So minus VD is equal to 0, second polarity. So from this, can you calculate the value for RD? So what will be your RD? VDD. So VDD minus VD is equal to ID RD, right? When you take it the other side. From this, what will be your RD? RD will be equal to VDD minus VD divided by ID, which is equal to RD. Okay. So that is what written here. VDD minus VD divided by ID, which is equal to RD. So VDD, you know the value is 15. VD, you know, you have assumed it as 10. ID is given 0.5 milliampere, 10 raised to minus 3. Okay. So you will be getting, when you solve it here you will be getting 5 divided by 0.5 into 10 raised to minus 3. So you will be getting 10 kilo ohm. Similar. So what is your RS? RS will be equal to the drop across this, right? What is the voltage across this VS? I am taking it as VS. Here it is plus to minus. VS divided by ID. The same current ID will be flowing. So Vs divided by ID, which is equal to, Vs is taken as 5 volt, ID is equal to, here also it is 10 raised to minus 3.5 milliampere, which is equal to 10 kilo ohm. Now you have found out RD and RS. RD is equal to 10 kilo ohm, RS is equal to 10 kilo ohm. Now what is your next step? You have to find out the value for your RG1, RG2, right? So for that you have to take your current equation ID. The required value of VGS can be determined by first calculating the overdrive voltage VOV. So what is your overdrive voltage? It is given by VGS minus VT. Okay, it can be got from your ID formula. ID is equal to, assuming that it is in the saturation region. Okay, working in the saturation region. So the value of the current is given by the formula 1 by 2 into Kn dash into W by L into over voltage the whole square. Can you substitute the values now? ID is equal to 0.5, 1 by 2 Kn into W by L is given, right? What is the value given? So this is nothing but your trans conductance. Okay, so Kn W by L is equal to 1. Okay, you have substituted the value of 1 and VOV the whole square. So from this, can you calculate VOV? So what you will be getting, 2 into 0.5 is equal to VOV square. So your overdrive voltage VOV is equal to 1 volt. After solving, you will be getting it as 1 volt. So what is your VGS? VGS is given by what is your VOV, that is VOV is equal to VGS minus VT. From this, can you calculate VGS? VGS is equal to VOV plus VT. That is what written here. VGS is equal to VT, threshold voltage plus your overdrive voltage, which is equal to, threshold voltage is also given 1 volt. So 1 plus 1, which will be equal to 2 volt. Now you have got the value for your VGS. Now since Vs is equal to 5 volt, what will be your VG? VG is equal to, so Vs is equal to 5 volt, right? So what will be your Vg? So it is given by the formula Vg is equal to Vs plus Vgs. How did you get this formula? When you can apply your input loop equation. Here plus Vg, here it is plus 2 minus, here it is plus 2 minus, right? So if I write the equation, what you will be getting, plus Vg plus 2 minus, so minus polarity, minus Vgs, here it is plus 2 minus, minus Vs is equal to 0. Vg minus Vgs minus Vs is equal to 0. From this, can you calculate the value for Vg? Vg is equal to Vgs plus Vs. That is how you are getting this equation. Vg is equal to Vs plus Vgs, which is equal to, you know, Vs is equal to 5. Then what is your VGS? You have calculated it as 2, which is equal to 7 volt. Now you have got the gate voltage as your 7 volt. Okay, as it is given in your figure. Sometimes if the figure is not given, you have to calculate by this order. So Vg is equal to 7 volt. You have fixed your Vg voltage is equal to 7 volt. If you want to find out, if you want to get this value 7 volt, to establish this voltage at gate, we may select Rg1 is equal to 8 mega ohm and Rg2 is equal to 7 mega ohm. The final circuit is given by, see, you are going to assume Rg1 is equal to 8 mega ohm and Rg2 is equal to 7 mega ohm in order to get Vg is equal to 7 volt. If you have doubt in this, you can apply your voltage division rule also. So what will be your voltage division rule? Vg is equal to VDD into Rg1 divided by Rg1 plus Rg2, right? It is across your Vg across your G2, Rg2, okay? Rg2 divided by Rg1 plus Rg2. So if you apply these two values, you will be getting it to be 7 volt, okay? So you are selecting, you may select Rg1 is equal to 8 mega ohm and Rg2 is equal to 7 mega ohm, since your Vg is equal to 7 volt. Usually your input resistance will be very high value in terms of mega ohm, okay? Now the final circuit can be given as, you can draw the final, reconfigure it with all the parameters, you can draw the final circuit. VDD is equal to 15 volt, RD 10 kilo ohm, RS 10k, VD 10 volt, VS 5 volt, both same ID current. Now here it is 8 ohm and RG 1, and here Rg2 is equal to 7 mega ohm, Vg is equal to 7 volt. So your first design is over. Now you are going for your second part. If the NMOS transistor is replaced with another having VT is equal to 1.5 volt, what will be the new value of ID? So now you are going to, your threshold value is changed now to 1.5, right? So you are going to substitute the value. ID is equal to half into what is this value, Kn dash into W by L into what is your value, VGS minus, that is VOB the whole square. Now the threshold is changed, so VGS minus VT, you are substituting the value for VOB, VGS minus VT the whole square. Instead of VT you have substituted the value of 1.5. Okay, now you already know the equation, VG is equal to VGS plus VS, right? VS is nothing but ID into RS. Now can you substitute the values? VG is equal to 7. VGS you have to calculate. Now RS you know the value, right? RS is equal to 10. 10K. Okay, here it is 10K. So 10 into ID. Now you, from this, can you calculate the value for VGS? What will be your VGS? VGS will be equal to, therefore from equation 2, VGS is going to be equal to 7 minus 10 ID. Right? 7 minus 10 ID. Can you substitute this VGS in equation 1? So what will be your value for ID? It is written here. ID will be equal to half into 1, right, into VGS. You are substituting the value 7 minus 10 ID minus 1.5 the whole square. So what will be your value here? ID will be equal to half into 7 minus 1.5, you will be getting 5.5 minus 10 ID the whole square. Okay. Now you can take here as 2 ID. 2 IDs, bring 2 to the opposite side. So A minus B the whole square. So what will be your value now? A square 5.5 whole square plus B square 10 square into ID square minus 2 into 5.5 into 10, right? 10 ID. Okay. So A square plus B square minus 2AB. You have substituted the value. So now finding the value, if you use calculator, what will be the value? 5.5 square is equal to, so you will be getting 30.25 plus 10 square is 100, right? 100 ID square minus, what is the value? 2 into 5.5 into 10, which is equal to 110 minus 110 ID. Okay, in here in the left hand side you have 2 ID. Now can you bring this 2 ID to this side? So when you solve it, you will be getting 30.25 plus 100 ID square. So minus 2. 2 when it comes this side, it will become minus 2, right? So you will be getting minus 112 ID. Is it looking in the quadratic equation form? 100 ID square minus 112 ID plus 30.25. Now you have to find out the value for ID. Either you can use minus B plus or minus root B square minus 4AC divided by 2A. So let me do it using calculator. So if I go to the mode equation 1, select the degree, let me select it as 2. It will ask the value for A. A is equal to 100 ID square, right? So A is equal to 100. What is your B? Minus 112 ID, right? And C is equal to 30.25. So what are the values you have got? You have got ID is equal to 0.665 and what is the next value you are getting? 0.454. Okay. So now you have got two values, 0.665 and 0.454. From this you are going to select the least value, 0.45. So you are going to select ID is equal to 0.455 milliampere. Okay. So now thus the change in the ID will be, what will be the change in the ID? Del ID will be equal to, now you have got 0.455 milliampere. Previously the given value was 0.5. So what is the change? Del ID is equal to 0.455 milliampere minus 0.5 milliampere, which is equal to 0.045 milliampere. What will be the percentage change now? Minus 0.045 milliampere divided by the previous value 0.5 into 100, which is equal to minus 9% change. So you will be getting a minus 9% change when it is replaced by another NMOS having VT is equal to 1.5 volt.